All right, hope you're doing well. We're looking at square roots today. We're doing all this without a calculator, but we can use a multiplication table. We've got the square root of 51. I'm trying to figure out if it's closer to 7 or 8. So if you look at 7 squared, 7 times 7, you see 49. So this means the square root of 49 is 7. And then if you look at 8 times 8, that's 64. And so the square root of 64 is 8. So when we look at 51, is that closer to 49 or 64? It's closer to 49. So the square root of 51 is closer to the square root of 49, which is 7. Same idea here. 9 squared is 81, so the square root of 81 is 9. 10 squared is 100, so the square root of 100 is 10. 86 is closer to 81, so the square root of 86 is closer to 9. Square root of 34, 5 squared is 25, so the square root of 25 is 5. 6 squared is 36, so the square root of 36 is 6. 34 is closer to 36, so the square root of 34 is closer to 6. Number 4, we got the negative square root of 81. So we can look for 81 on our multiplication chart and we see it. It's one of those perfect squares. You might have it highlighted. And so that's the negative. Negative just stays in front. Negative 9. The negative square root of 81 is negative 9. Because negative 9 times negative 9 is also 81. And then looking for 100 in our table, we see that the square root of 100 is 10. Because 10 times 10 is 100. If it doesn't have a sign in front of the square root, it's just going to be a positive. We call that the principal square root. Number 6 is square root of 500. Now that's not a perfect square. If you look at your table, you won't see it there. Even if we extend the table out, it's not a perfect square. But we can do a factor tree and do maybe 5 times 100. And then 5's prime, but we can keep on going with the 100, maybe 10 times 10, 2 times 5, and 2 times 5. So our prime numbers at the end of this factor tree are 5, 5, and 5, so 3 5s, 3 factors of 5, and then 1, 2 factors of 2. Now we're looking for pairs of the same number. Square root of 5 times 5 is 5, the other 5's left underneath the radical. Square root of 2 times 2 is 2, and there's no 2's left underneath it. 5 times 2 gives us 10 square root 5. Alternate way of approaching it is to see that 100 is a perfect square factor. We can take the square root of 100 and get 10. So we get 10 square root 5. So either way of thinking through it is fine. #17, we have the square root of 14 times the square root of 14. You can multiply 14 times 14, but then you're going to have to take the square root of it. Or you could think of it as an exponent. Square root of 14 squared is just 14. Number 8, 162. Not a perfect square if you look at your list, but we can know that 2 is a factor because anytime it's even, 2 is a factor. So let's see how many times 2 goes in there. 2 won't go into 1, but 2 will go into 16 8 times. 8 times 2 is 16. Subtract, you get 0, bring down the 2. 2 will go into 2 one time. 1 times 2 is 2. Subtract, you get 0. So 2 times 81 is 162. You could do 9 times 9, and you could do 3 times 3. So our factor tree ends with 1, 2, 3, 4 factors of 3 and a factor of 2. Square root of 3 times 3 is 3. Square root of 3 times 3 is 3. And then we're left with that 2 underneath the radical. 3 times 3 is 9. So 9 square root 2. This is the simplest way we can write the square root of 162. Now you may have noticed that when you divided it by 2, you got 81. So 81 times 2 is 162. Square root of 81 is 9. It's a perfect square. So if you happen to notice that, you would not have to do the factor tree. Number 9, 4 square roots of 5 plus 3 square roots of 5 is 7 square roots of 5. Number 10, we got like radicals as well. 2 square roots of 3 minus 7 square roots of 3 is negative 5 square roots of 3. These like radicals you can think of as like terms. So some similar problems would be like 2x minus 7x, which gives us negative 5x. 4x plus 3x would be a similar problem. That'd be 7x. Same idea as combining like terms when we combine like radicals. Number 11, we got not like radicals, so we've got to do something with it. So let's look at the 40 and see if we can simplify that any. You can go to a factor tree, maybe 4 times 10, 2 times 2, 2 times 5. So we can write it as 2 times 2 times 2 times 5. Looking for pairs of the same number, we see a pair of 2's, so we can take the square root of that and get 2. And we're left with 2 times 5 underneath it. Now 3 times 2 is 6, 2 times 5 is 10, so we've got 6 square roots of 10 plus 8 square roots of 10. So we get 14 square roots of 10. Again, we had to get those to be like radicals before we could combine them. Number 12, we got square root of 18. You might think of 3 times 6, 3 times 2. So we have 2 factors of 3 and a factor of 2. Square root of 3 times 3 is 3. So we have 5 times 3 times square root of 2 times 6 square root of 2. And so 5 times 5 is 25. Square roots of 2 times 6 square roots of 2. Now we'll multiply the numbers in front. 6 times 25, 6 quarters, 150 cents. And then square root 2 times square root 2 is square root 4, or just 2. And so we get 300 for our final answer here. And I just thought of a different way to work it as well. We can multiply the numbers in front. 5 times 6 is 30. Multiply the numbers underneath the radical. 18 times 2 is 36. Oh, my fault. I should put a 3 here. Square root of 3 times 3 is 3. So that'll be 15 square roots of 2. Alright, that makes more sense. 15 times 6 gives us 90. 90 times 2 is 180. Alright, square root of, back over here the other way, multiply the numbers in front. 5 times 6 is 30. Multiply the numbers underneath. 18 times 2 is 36. And then square root of 36 is 6. So 30 times 6, 180. Alright, this time we've got a square root in the denominator. We want to get rid of that, so we'll multiply the top and the bottom by square root 7. And so we get 3 square root 42 over square root 7 times square root 7. Square root 49, or just 7. That's as far as we can go with it. If you do a little factor tree on 42, you get back to 6 times 7, 3 times 2. So you don't see pairs of the same prime number. So it won't simplify any. Root of 121 is 11. Square root of x to the 10th. You can think of it in terms of division. 2 goes into 10. 5 times no remainder. Same thing for the y to the 12th. 2 goes into 12, 6 times no remainder. We need absolute value around any time it starts as an even, ends as an odd. 15, we've got the square root of 60. Let's do a factor tree on that. Maybe 6 times 10, 3 times 2, 2 times 5. So we have a pair of 2's there. All right, so we can write that as 2 times 2 times 3 times 5. Square root of 2 times 2 is 2. We're left with the square root of 15. Now for the variables, 2 goes into 20, 10 times, no remainder. 2 goes into 12, 6 times, no remainder. So final answer here, 2x to the 10th, y to the 6th, times square root of 15. (16) We don't have like radicals at the beginning of the expression, but we can go ahead and combine the other two. Negative 6 squared root of 5 plus 2 squared root of 5 is negative 4 squared root of 5. Now I'm going to work with that square root of 20. You could do 4 times 5, 2 times 2. So we see two factors of 2 and a factor of 5. Square root of 2 times 2 is 2. So we have 4 times 2 times square root of 5. So that's 8 square roots of 5 minus 4 square roots of 5. And so we get 4 square roots of 5 for our final answer. Now we can combine those like radicals. Square root of fraction is the square root of the numerator over the square root of the denominator. And so we get 6 over 12. Now this is a fraction, so we can divide them both by the same number. We can reduce it. In this case, we can divide them both by 6 and we get 1/2. So final answer, 1/2. Here we'll subtract 4. To get rid of squared square root, don't forget about the positive or negative on one side. 6 times 6 is 36, so we get positive or negative 6. This time the square roots are, or the squared is already by itself, so let's square root. But when we try to take the square root of a negative number, we get no real solution, or no real root. So no real solution, or you can write no real root, whichever way you want to say that. When you get to algebra 2, you'll work more with those imaginary numbers. To get rid of plus 11, subtract 11. Get 4x squared equals 144. To get rid of multiplying by 4, divide by 4. 4 goes into 14 3 times, multiply, you get 12, subtract, you get 2, bring down the 4. 4 go into 24 6 times, 6 times 4 is 24, subtract, no remainder. So we have x squared equal to 36. To get rid of squared, square root. Don't forget about the positive or negative, and so we get positive or negative 6. Hopefully you've been able to figure out any mistakes that you had. As always, feel free to pause and rewind and listen to it again if you need to.